Up until now, I've done examples where we only use the main function, but as our programs get bigger, it's a good idea to break the code up into multiple functions. It makes our code much easier to follow, and in today's video, I have 3 separate functions. I also broke them down into 3 separate programs, so we're going to have 3 C files to compile. IsPrime.c will tell the user if the inputted integer is a prime number. Isfib.c will tell if it is a Fibonacci number. And Fibonacci prime.c will take in a range of numbers from the user and determine if any of the numbers in that range is a Fibonacci prime number. So first I'll explain how to determine if a number is a prime number. All of our code for this program will be done in this one method that I call isPrime. It contains a parameter called num that will represent the integer that is passed to this function when we call it. To begin, I check if num is less than or equal to 1, because we are not dealing with negative numbers and 0 and 1 are not prime numbers. Once this program finds out if num is not a prime number, we return 1, and this is going to be used by our driver program to figure out whether a prime number was found. A driver program is a program that contains our main function and is where we're going to take in the input from the user. Next, I wrote a for loop that initializes x to 2 and will iterate as long as x is less than the number that we take in. After each iteration, x will increment by 1. Inside the for loop, we check if num mod x equals 0, because if this is true, it means the number we took in can be divided by another number that is not itself or 1. If this is true, it means that the number is not a prime number, and we want to return 1. If it cycles through the whole for loop without the if statement evaluating to true, then this means that our number is prime and we reach the return 0 statement below. That was a quick explanation, but I did cover the mod operator and for loops in the last video, so hopefully they weren't too confusing. There's also a few different ways to check if a number is prime, but this one made the most sense to me. That's it for this example. The next program is figuring out if a number is part of the Fibonacci sequence. On top of the standard library, I'm also including the math header file. This contains a bunch of pre-written functions related to math. The one we will be using is the sqrt function, which returns the square root of a number. For this program, all the work is being done in one function again, which takes in an integer and returns 0 if it is a Fibonacci number and 1 if it is not. Figuring out if a number is part of the Fibonacci sequence is a little bit more confusing in my opinion. There are less ways to do it and they aren't as intuitive. As you can see, I use a few more variables than in the last example. The names are a little bit confusing, but I'm going to explain them now. Pre plus minus is going to be our number we take in multiplied by itself and then times that by 5. This is just one of the steps needed to determine if it is a Fibonacci number. The variable is called this because the next step is to plus 4 to that value we just calculated, and then after that we are going to do the same thing except minus 4 from the variable. Hopefully that makes sense. You could also do this without the pre plus minus variable by just doing I times I in brackets, then times 5, then plus or minus 4, but that sounds more confusing, so I decided to store it in a variable. Next is where we use the math library. We want to take the square root of the plus variable and of the minus variable, and I'm storing that value in result p for plus and result m for minus. Now that is the bulk of the code for this program. The next little bit are just some comparisons. It turns out if the truncated value is the same as the value before we truncated it, then it means it's in the Fibonacci sequence. While it's not very intuitive, I think it's pretty cool that doing those random operations will tell us if it's a Fibonacci number or not. Again, you could have not used variables for truncated and it would have shortened the code. Anyways, here's the last part where we say if truncated p equals result p, then return 0. Also, you can see below I do the same thing for truncated m, and this is because it doesn't matter which one is true, as long as one of them or both of them are true, then it means a value is a Fibonacci number. But definitely include both cases because some Fibonacci numbers are one and not the other and vice versa. This last piece of code is if it is neither of those cases, then it must not be a Fibonacci number, and therefore we want to return 1. Our driver program will use these return values in the next example. So that's it for isfib.c. That was probably the most confusing part of the video. The next program just ties the 2 previous programs together. This is the final program for this video. We will be asking the user for a range of numbers, like 10 to 100 for example, and our program will go through each number in that range and check if it is a Fibonacci prime number. If it finds any, it will print those values to the screen. Having the 2 functions that we previously created up at the top here, is known as method stubbing. This is so when the compiler reaches these functions in our main method, it knows what they are. Since they are not written out in this program, we should stub them here to avoid any errors. This is also worth doing if I had the function written underneath of main and I was calling it inside of main. Since the code executes from top to bottom, the compiler would complain because I'm trying to use a function that it hasn't encountered yet. So method stubbing avoids those kind of errors. Here are the variables I'm going to be using. x1 and x2 represent the two integers that we receive from the user. IERR is a variable to deal with error handling, since we are looking for a specific data type from the user. Largest is to determine what integer is the largest in case they don't put their range in order from smallest to biggest. Finally, fib return and prime return represent the value returned from those functions when we call them. I set the IERR variable to whatever scanf returns, which will be 2 if there are no issues, but in case there are issues, I have this while loop. The while loop will be evaluated to true if IERR does not equal 2, in other words, if the user didn't give us 2 integers, or if the integers are below 1, since we only want to work with positive numbers. When the input is incorrect, the print statement asks the user for input again, and scanf will rescan looking for 2 integers. I went with a while loop instead of an if statement, so the user has an opportunity to give a correct input without having to rerun the whole program. After error checking, I check to see which value is the largest, in case the user didn't enter the integers in order. So if x1 is less than x2, or if they are equal, I'm going to say that the largest is x2. I wanted the program to still run if the user wanted to check only one number, so I'm just picking the second to be the largest to make it work with the while loop, which I'll explain soon. And then I have an else statement to go with the if statement that says if x1 is not less than x2, then set the largest variable equal to x1. Here is a while loop. The condition is while x1 is less than largest, so it will go through each number in the range that was provided to us. Then I set fib return equal to the return value from calling isFib with x1, and I do the same for isPrime. Next, I want to check if x1 was a Fibonacci number and a prime number. I did this by using an if statement, checking if both return variables were equal to 0. If they both were, then I want to print the value to the screen and tell the user that it is indeed a Fibonacci prime. Finally, I increment x1. It might look a little weird that I did not use x2 in the while loop, but it's not needed. We just need to know when to stop looping, and that will be the value of largest, whatever that may represent. If x2 is largest, then we will loop from x1 and increment x1 until it reaches x2. In this case, the final iteration of the loop would be checking if x2 is a Fibonacci prime. The only difference is the variable name would be x1. Hopefully that made sense. If you wanted to print out the initial values at the end of the program, then you wouldn't want to do it this way since we are changing the actual value of x1 at each iteration. But for simplicity, I just chose to print out the values of the Fibonacci primes. I should mention a minor thing on return statements. I said in a previous video that unless our function was void, we need a return statement. And I should clarify that. You should make the function void if you are not planning on returning something. However, you can leave the main function without a return statement. If it reaches the end of the function without finding a return statement, the compiler will automatically treat it as if you return 0 at the end of the function. Now I'll show you how to compile multiple programs because it is slightly different. So here are the 3 commands needed. The only main difference is we are going to compile each program on the same line and then take out the -c compile tag and include all 3 programs, then the -o flag for output, and the name of what you want your executable file to be. Nothing changes for the last command, just type // and then the name of your executable file. And once I hit enter, it will ask for the range. And if I give it 0 and say 1200, 1 and 1200, then you can see that there are 6 Fibonacci primes within that range. That is all for this video. I'm planning to start pointers in the next video if you want to check back for that. And thanks for watching.